In this example, we start from a box and adjust its size. We then select the non-terminal object and load a facade module under a certain name. A variety of non-terminal objects is created and several parameters are provided. Changing the camera view reveals parameter manipulators on a large scale or on a small scale. We then click on one of the red non-terminal objects and replace it by a module to embed a window. Again, we can adjust the parameters or click on a non-terminal object to replace it. In this case, we choose a window. The window also provides a lot of parameters on different scales, but the camera views help the user to concentrate on a small subset. This high-level primitive also creates some abstract sliders to change the color. At any time, we can click on an instance and trace back the high-level primitives that were used to generate the clicked instance. Here we change the parameters of the embed module. Note that all windows change their size due to the procedural nature. By choosing certain texts that are defined by a high-level primitive, the changes can be restricted to a subset of instances. Different selection patterns are provided, like for example a symmetric pattern that will select certain instances from the left and from the right with respect to some offset. Note again that we can trace back all high-level primitives at any time. For example, we change parameters of a very early stage in the replacement process. We now repeat the same interaction concept to insert a door and to change the color of the side stones. In the final facade, any parameters can still be adjusted easily. In this example, we created a small database as a proof of concept for the creation of plants. Starting with the forest high-level primitive, the user can adjust the random seed and the number of seed points for the placement of the trees. Due to the complexity of the trees, we start with only one seed point. First, we place a base tree structure at the seed point. Here we can adjust parameters like the recursion depth, the number of attached limbs, the tropism strength, and the random seed. The user can now select one of the provided arrows to attach a limb with further parameters. In this case, we use a fruit limb where the user can adjust the basic length, the variance in the length, and the probability for attaching fruits. We now place several terminal high-level primitives for the final appearance. At any time, parameters on a parent level can still be adjusted, such that we are able, for example, to place some more trees. In this example, we created a complex manipulator object that is a stick figure. It provides length and angle measures. Furthermore, we created a high-level primitive of a chair providing lots of parameters. Finally, we attached the stick figure to the chair by creating a new high-level primitive defining the parameter dependencies. When the stick figure is now manipulated, the chair will adapt these changes and vice versa. Note that only a subset of parameters is still accessible for this echo chair to avoid unwanted configurations. This is a professional mode in which we want to create a chair from scratch in a strict cost-to-find manner. Although the grammar can be textually edited at any time, most of the operations can be controlled interactively. Let's now insert a rule S, which is the entry point in our grammar. Each rule can have several conditions or probabilities which can be defined in the purple and cyan brackets respectively. Let's now insert the first operator to the start rule in order to change the size of the box. We now add a parameterized shelf rule and associate the current box with it. The parameter t stands for some thickness that will be used within the shelf module. Let's prepare two further rules for the walls and the inner part of the shelf, which will be subdivided several times. We add a split operator to divide the box along the local z-axis. The first part will be associated with the wall rule and should have a thickness of t. Since this part should have an absolute sizing policy, we change the corresponding parameter. The second part of the split should use the remaining space. Therefore, it has a relative sizing policy. We then associate this part with the inner rule. We now apply several more subdivisions in the same manner. Note that most rules do not need to have a specific name since they are only used one time. For this purpose, the user can create automatic rules whenever an operator creates new non-terminal objects. For the innermost part, we use the repeat operator as the inner planks should occur in regular distances. Finally, we change the color of all resulting elements. This is a shelf layout which was requested in the user study. To step a little bit deeper in the professional mode, we want to add a door to the shelf that can be opened when the shelf module is selected. For an intuitive workflow, the user can click on any instance and trace back the operator hierarchy. In this case, we want to add a further split along the z-axis in order to place a door in front of the shelf. We then create a new door rule and associate the new part with it. We now add a rotation operator and change the color of the door. Since we want to be able to set the opening angle from outside the shelf module, we have to add a certain parameter and pass a value to the shelf module. To associate this parameter with an interactive manipulator, we add a certain operator to the door rule and associate it with a new parameter. If we now select the rule link, the parameter manipulator becomes active and we can interactively change the opening angle. To demonstrate the problems of conditions in the professional mode, we add a condition for the door rule. Let's say, for example, that the door should only be created if the shelf is higher than a value of 2. If we now reduce the height of the shelf, the door disappears, and most importantly, if we select the rule link, we are not able to change the opening angle, although it is still passed to the rule as a necessary parameter. This is a high-level mode in which we want to compose a shelf from scratch. Starting from a floor plan, the user can insert shelf modules. In this scenario, a company X just provides one type of shelves. By clicking on the shelf and using the mouse wheel, any parameters of parent high-level primitives can be adjusted. Repetitive objects of a high-level primitive provide text that are shown on the right side of the application. By choosing a certain selection pattern, like every nth, only some of the instances are affected. By these simple interaction concepts, a complex procedural object can be composed from the high-level primitives. Note that the grammar is never exposed to the user. The rest of the video will be played in quad speed. This is the final shelf that had to be composed in the user study. Thank you for watching the video.